You know that feeling when your phone finishes your sentence for you, or when your streaming service recommends a show that is just, well, perfect? That's artificial intelligence. It's a phrase that's everywhere, but what does it actually mean? Okay, let's pull back the curtain and really figure this thing out. And if your head is already spinning with all the acronyms AI, ML, AGI, deep learning, and you're trying to figure out how they all connect, you are in exactly the right place. Because you are definitely not the only one feeling that way. So, in this explainer, we're going to build a kind of mental map, a really simple but powerful framework to help you make sense of the entire AI landscape. We're starting from square one. To get started, we've got to ask the biggest, most fundamental question of all. When we say we're building intelligent machines, what is it that we're actually trying to build? At its absolute core, AI is just this. The idea of creating computer systems that can do stuff that usually takes a human brain. Like recognizing a face, understanding language, or making a decision. AI is all about trying to simulate that intelligence in a machine. And this whole quest, this whole field of study, really kicked off with this one simple but world-changing question from the father of computing, Alan Turing, all the way back in 1950. Can machines think? That question didn't just start a conversation, it basically lit the fuse for everything that was to come. See, Turing's question opened up this huge new world of possibilities. And to really get a handle on it, we need a way to organize our thoughts. And the best way to do that starts with one crucial difference: the difference between a machine that thinks and a machine that acts. Okay, this grid might look a little academic, but trust me, it is the single best tool for making sense of the different goals of AI. On one side, you've got the difference between trying to be human-like versus being perfectly rational. And on the other, you've got the focus on the internal thought process versus just the external result, the action. Let's pop open each of these four boxes. So first up, thinking humanly. This is the psychologist's approach. It's all about trying to crack the code of the human brain itself. The goal here is to understand our own thought processes so well that we can actually build a computer model that thinks in the same messy, creative, and sometimes illogical way that we do. It's about copying the process. Now, acting humanly, this is the classic Turing test we just mentioned. The goal here isn't to build a model of a human brain, nope. It's to build a machine that can imitate human behavior so perfectly that you literally can't tell if you're talking to a person or a computer. It's all about the output, the performance. Then you've got thinking rationally. This is the logician's approach. It has nothing to do with being human. It's about being perfect. This is about building systems that operate on pure, cold, hard logic, like a math proof. The only problem? We humans are almost never that perfectly rational. And that brings us to the last box, acting rationally, which is where almost all the action in AI is today. Why? Because it's practical. It works. Just think about a self-driving car. Do you care if it thinks like a human driver? Or do you just want it to make the best possible decisions to get you there safely? Right. It's about creating agents that do the right thing to get the best result. Okay, so now we have a framework for the goals of AI. The what? But that still leaves a huge question unanswered. How do we actually get the machines to, well, to learn? The road to answering that question has been a long and fascinating one. The history of AI isn't some straight line of progress. It's really a story of huge booms followed by pretty dramatic busts. After all that early excitement in the 50s and 60s, researchers kind of hit a wall. The problems were way harder than they thought, the funding dried up, and the whole field went into what they call an AI winter. But those winters were actually incredibly important. They forced everyone to rethink their approach, to move away from trying to write a rule for everything and toward a totally new idea, machine learning. And this is where everything changed. Seriously, machine learning completely flipped the script. Instead of a programmer having to sit down and write code for every single possible situation, they can now just show the machine a ton of examples, a ton of data, and have it figure out the patterns for itself. It's the difference between following a recipe and actually learning how to cook. And deep learning, well, that's like machine learning on steroids. It uses something called neural networks, which are loosely inspired by the structure of the human brain. And this allows deep learning systems to find much, much more subtle patterns and, get this, learn from their own mistakes without a human needing to step in. The trade-off? It requires two things: an absolutely mind-boggling amount of data and some seriously powerful, specialized computer hardware to run on. And you can see this evolution perfectly with these three examples. Back in 1997, IBM's Deep Blue beat the world's chess champion. It was amazing, but it was basically just a huge library of hand-coded rules. Then, in 2011, Watson won on the game show Jeopardy! Using machine learning. It learned by reading and understanding millions of documents. But 2015? That was a different level. DeepMind's AlphaGo beat the world's best Go player, not by being taught the game, but by teaching itself. It played millions of games against itself and discovered strategies that humans had never even thought of. That is the power of deep learning. So that brings us to today. After all that history, all that theory, what does AI actually look like out there in the real world right now? All right, this might be the single most important thing to remember from this whole explainer. Every single AI system you interact with today, from your smart assistant to the most complex scientific tool, is what we call narrow AI. That means they are incredibly, superhumanly good at one specific task. AlphaGo can't write you an email. Your spam filter can't drive a car. They are all hyper-specialized. But listen, narrow does not mean simple. Not at all. Within narrow AI, there's this huge spectrum of complexity. You start with simple agents that just follow if this happens, do that rules. Then you level up to goal-based agents, like a warehouse robot that can plan a route. Then you get to learning agents, like your recommendation engine, that actually get smarter over time. And at the top, you have entire systems of AIs working together to solve massive problems. And this isn't some future tech. This is happening right now. It is reshaping entire industries. In healthcare, it's taking mountains of patient notes and creating perfect summaries for doctors. In finance, it's finding fraud patterns that no human ever could, and even simulating cyber attacks to find weak spots. And heck, even in sports, it's explaining complicated rules to fans in plain English in real time. So if everything we have today is narrow AI, what's next? Where is this all going? What's the end game? Well, the next great frontier, the sort of holy grail of the field, is something called artificial general intelligence, or AGI. This is the theoretical idea of an AI that has the same kind of flexible, adaptable, general-purpose intelligence that we do. An AI that could learn pretty much any task a human can and move between those tasks seamlessly. But building AGI isn't just a matter of more data or faster chips. It might require us to completely rethink how we build computers from the ground up. You see, for decades, we've built our computers to be predictable, to be deterministic. They follow the rules perfectly. But real intelligence, it's messy, it's adaptable, it deals with uncertainty. And building a machine that can do that might mean inventing a whole new kind of computer architecture. And really, that brings us to the most important point of all. The conversation has moved on. It's no longer a question of if we can use AI. That's a done deal. The real question, the one that we all need to start thinking about right now, is so much bigger. How is this technology going to fundamentally change the way we work, the way we create, and the way we live? That's the challenge and the incredible opportunity that's right in front of us.